Welcome to the Chapter 3 video lecture. We'll see how far we get, because I do want to try to keep the videos from 30 to 45 minutes. Not too short, not too long. So we'll see how many sections we cover. Just a quick reminder that the video lecture notes outline should be available in Blackboard under course materials, and you probably want to print that out double-sided before you proceed with the video lecture, so that you can have really good notes to use to study from. So 3.1 is an introduction to equations. Recall in Chapter 2 we dealt with expressions which do not have equal signs, and equations do have equal signs. Objective A is to determine whether a given number is a solution of an equation. All you're going to be doing is substituting a value into the equation for the variable and seeing if you get a true statement. Definition: an equation expresses the equality of two mathematical expressions, either numerical or variable. A solution of an equation is a number that, when substituted for the variable, results in a true equation. So this is a more formal definition of what I've already said. So notice that we have an equal sign. That's the equation. And each, the left and the right-hand side, are variable expressions. So they're mathematical expressions, either numerical or variable. They both have variables in them, so they're variable expressions. And they're set equal to each other. This question asks, is 5 a solution of this? So what we're going to do is substitute 5 in everywhere we see an x. And one of the things to note, if you recall from one of the previous videos, everywhere there was an x, I'm actually putting parentheses and then filling in the parentheses with the numerical value that it asks us for. Because if you recall from one of our examples, if this were a negative 5, and I just wrote negative 5 squared, and then you have this subtraction symbol sitting out here, things can get really confusing. But if you set it up with the parentheses right away, then you're taking whatever that solution is and plugging it into the parentheses. You can keep track of your negative signs better that way and keep track of what's happening. So now we're going to start simplifying both sides. This is 50. 5 squared is 25. And this whole time we're actually have a question mark here. We're asking ourselves, does one side equal the other? Do they equal each other? 50 minus 25 is 25. 15 minus 5 is 5. So the answer is no. 5 is not a solution. Now in a quiz or an exam, I might not just ask you that, but I might also ask you to explain. And what I'm looking for when I say explain is 5 did not create a true equation, and that's why the answer is no. Okay, if we had gotten 25 equals 25, then you could say yes, because 5 creates a true equation. And so on a quiz or an exam, if I ask you to explain, then I'm asking you to give me these keywords about whether or not it creates a true equation. Objective B: to solve an equation of the form x plus a equals b, where a and b are constants and x is the variable. To solve an equation means to find a solution of the equation. We previously saw some mathematical properties of addition and multiplication with expressions, and now we see some relating to specifically to equations. So that's why on a quiz or an exam, if all you say is addition property, I'm going to be like, well, addition property of what? Well, this time we're talking about the addition property of equations. The same number can be added to each side of an equation without changing its solution. The equation a equals b has the same solution as the equation a plus c equals b plus c, because c is the same thing. And a quick integer example. I'm going to take a step back and say that 3 equals 3, and we accept that that's a true equation. This is true. And we're just going to call 3a and 3b for the purposes of matching them up for here. C equals 5, and we're adding the c to both sides. And we get 8 equals 8. That's a true equation. So what this is saying is that if you have two things, and this is a simple integer example, but when you're dealing with rational expressions, it's a little bit different. When you add the same exact thing to both sides of an equal sign, it's not going to change the solution. So 3 equals 3 was a true answer, and now 8 equals 8 is also true. So it doesn't automatically change it to a false statement. This property allows you to isolate the variable by removing a term from one side of the equation by adding the opposite of that term to each side of the equation. The ultimate goal is to isolate the variable and end up with something that looks like variable equals constant. So solve and check. So we want to isolate y. So here's the thing. A lot of algebra students want the variable to be on the left-hand side, but it doesn't matter if the variable is on the left-hand side or the right-hand side. In a quick example, if I tell you that x equals 5, well, doesn't that also mean that 5 equals x? Okay, so they mean the same thing, so it doesn't matter. I like to keep my variables positive, so if at all, I'm going to try to keep the variable positive on whichever side it's already positive on, and y is positive here, so I'm not going to move it to the left. I'm going to leave it there, which means I have to get rid of the negative 14. So we have to do the opposite of what's there, and this says we're going to add the opposite of the term to each side. To each side. And just like above, when I added 5 to both sides of the equal sign, we're going to add 14 without changing the solution. So we get y. This zeroes out. 26 plus 14 is 40. So y equals 40. If you want to switch it around, you get y equals 40 that looks like that. So the answer is 40. Now, it wants us to check. So I didn't leave a lot of room for checking. So you're going to ask yourself, 26, does that equal question mark 40 minus 14? Here's something I want you to watch out for. On quizzes or exams, I actually want you to take it to the very last step and show me that 26 equals 26. Yes, we can all do in our head, maybe, that 40 minus 14 is 26. But I don't want you to just start checking here. I want you to get it to where one side actually equals the other. And then check. So when I say solve and check on quizzes or an exam, and if you do not check it, you lose half the points at least. Solve and check means each part of those is worth half of the points on a quiz or an exam. If I just say solve, you still might want to check it because you can leave that quiz or exam knowing that you've already done it correctly if you get a true statement. Most of the time. Every once in a while, a student will do this improperly, and then they'll also check improperly, and magically it comes out to a true statement. So you just have to be careful for that, but most of the time if you check it, it creates a true statement, then you're just fine. Now, one other thing we could be doing here, if I don't say list the mathematical properties, you don't necessarily have to, but if once in a while you want to try to go for a little bit of extra credit, if I'm in a good mood, then you're going to say, oh, this is the addition property of what? Of equations. And if all you want to do is put EQ, I am fine with that. I understand what equations means. When we get to chapter 9, we're going to be dealing with inequalities, so then I expect it to say INEQ. But this might get you half a point extra credit, maybe a point extra credit, depending on what this problem might be worth. Unless I automatically say list the mathematical properties, then you have to list them or you will lose points. So just giving you just some hints as to how I grade and what I'm looking for along the way. So we're solving and checking. Now this time n is positive on the left-hand side, whereas y was positive on the right in the previous problem. So we're going to subtract. We're adding the opposite. We do the shorthand and we call it subtraction. What we could say is we're going to add the opposite. We're going to add the opposite. And we get n equals 1 plus a negative 11. And if we recall from chapter 1, one of the very first sections we talked about is when we're adding numbers with different signs, we take the absolute value of them and then we subtract the smaller from the larger, and then we apply the sign with the larger absolute value. But by now, hopefully, you know that 1 plus a negative 11 is negative 10, or actually, and that actually is the correct answer. My little typed answer is incorrect, so just add a little negative sign if I haven't already corrected it for you in your copy. And then this checks. Well, it doesn't really check. We check it because it checks against our answer, but if we want to actually check it, everywhere we see n, we're going to put negative 10. And the first line is always a question mark. Negative 10 plus 11 is 1. 1 equals 1. So in fact, I'm pretty sure now, 99.9% sure, that my answer is negative 10. And I'll try to update that before I put it on Blackboard, but if I don't, just make a note that that should be negative 10. One thing I'd like you to do on quizzes or exams as well is box your answers. So that's why all my answers over here are properly boxed, but you're going to be doing it by hand. So just box your answers so that I can more readily find them. That would be a great help. It's a great help to all teachers to make your work as easy as possible to deal with. Objective C, to solve an equation of the form ax equals b. Now we're dealing with multiplication. And we're going to talk about the multiplication property of equations. Multiplication is happening right here between an a and an x, where a and b are real numbers. If they sit right next to each other, they're talking about multiplication. So we don't do something like 3 times x equals 6. We just say 3x equals 6, and we understand that this is multiplication. So the multiplication property of equations says each side of an equation can be multiplied by the same non-zero number without changing the solution of the equation. So if c, some non-zero number, and that's what this means, it doesn't equal 0, so it's non-zero, then the equation AB has the same solutions as the equation AC equals BC. This property is used to remove a coefficient by multiplying each side of the equation by the reciprocal of the coefficient. And we're going to start with something a little bit harder, but up here, this 3x equals 6 we can actually work on. We want to multiply each side by a number such that we end up with just x on the left-hand side. And now I know all of you are going to say, but why can't we just divide? And one of the things I want to point out is I'm going to try to use the word subtraction and division as little as possible, since none of these properties actually say subtraction or division. Subtraction is just the opposite of addition, and division is the opposite of multiplication. And so none of these properties actually say subtraction or division within them. So instead of dividing by 3, and let's look at what that actually looks like. When we divide by 3, what we're actually doing is multiplying by the reciprocal. And notice 1 times 3 is 3, and then there's the 3 here. So we're going to multiply both sides of this equation. I'll do it in a slightly different number here. By 1/3, which is the reciprocal of 3. Now, 3 over 3 is the 1, and so we've isolated our x. And some of you want to put 1x there. That's fine for now if you want to use that, but I'm going to suggest that you move away from that as soon as you can. And then now we have 6 times 1/3, which hopefully you can see that that's 6 over 3, and 6 over 3 is just 2. And if you were to check that, 3 times 2 as our x does in fact equal 6. So that's an easy integer example, but now we're going to deal with fractions. And the reason I wanted to throw a harder problem right away is so that we could talk about multiplying each side by the same non-zero number. The coefficient of this can be written as -2/5 times x equals 6. We need to take the opposite of this. The opposite means flipping it. Oh, sorry, let me not even use the opposite. Don't have me use the word opposite. Just erase that. If I could edit the video, I would, but I can't. We want to take the reciprocal, not the opposite, because I don't want to change signs. I want to multiply this by a negative because I want to isolate x and make x positive. So we're going to multiply, and I'll do it in a separate color again, by the reciprocal of -2/5, which is -5/2. And the one thing I want to caution you about is that a lot of students, when isolating the x with a fraction, they write -5/2 on this side, but then on the right-hand side they get rushed or confused, and they write the coefficient instead of writing this number. So maybe you want to like underline it to remind yourself which fraction you're multiplying by. Maybe you want to box it so you remind yourself which number you're multiplying by. But you want to make sure that you're multiplying both sides by the same exact number. So now proceeding back with our normal color, we get -5/2 times -2/5. The 5's cancel, the 2's cancel. What's left is just a 1. The purpose of multiplying this by the reciprocal is to make it just 1. It's to isolate our x and make it 1x. If you need to follow this through, the negative times the negative becomes a positive. 5 times 2 is 10 in the numerator, 2 times 5 is 10 in the denominator, and 10 divided by 10 is your 1. Now we have 6 times -5 over 2, and I'm going to actually cancel some factors instead of multiplying across. 2 goes into 2 once. 2 goes into 6 3 times. 3 times the -5 is -15, and that matches our answer box. One thing I want to point out again, which we talked about, I believe, in chapter 1, was canceling factors. Don't just leave nothing there, because some students misinterpret that as being 0 then, because they've canceled out whatever was there, which means nothing's there anymore. But really, the 1 is there, and the 1 should remain there. Now, if all I say is solve, but you're like, I really want to know if I got this right before I walk out of the quiz or the exam, you could check it. So we have our -2/5, and then we have our x, which is -15, and we're asking ourselves, does that equal 6? Well, the negative and the negative definitely make the positive, and now we have 2/5 multiplied by 15 if we make these positive. So the 5 goes into 5 once, and I am writing the 1 there, and the 5 goes into 15 3 times. So now we have 2 times 3, which is 6, and 6 in fact does equal 6, so that checks. One thing to keep in mind is some students get confused when they're multiplying a fraction by a whole number, and then they all of a sudden either start multiplying both the numerator and the denominator by the 15, or they multiply the denominator by the 15 instead of the numerator. So if it makes it easier for you, you can put the 15 over 1, and then you can more clearly see that the 15 is meant to be the numerator instead of the denominator, or both. Because I have had students actually multiply both by that number instead of just the numerator by the number. So we want to keep our numerators together and then our denominators together. So now we're going to look at a slightly more complicated problem, but at least it deals with integers. Well, first thing we have to do is combine like terms. And notice previously I didn't list the properties. Maybe we'll do that now. So we tend to think of this then as division when we're looking at these, which is what I explained with our 3x equals 6 example at the top of the page. 4x minus 8x, we're going to combine like terms, and we're going to get negative 4x equals 16. Now I'm going to use the multiplication property of equations, and I know my writing is terrible on the tablet sometimes. Mult means multiplication, prop means property of equations. And we're going to multiply both sides by the reciprocal of negative 4, which is negative 1/4. And again, I'm multiplying both sides by the same exact number. So again, the purpose of multiplying it by the reciprocal is to 1 that out. So the negative 1 times the negative 4 would be a 4. You divide the 4 by 4 and you get a 1. Now, 4 goes into 4 once, so that leaves a 1 in the denominator. 4 goes into 16 4 times, that leaves a 4 in the numerator. And then what's left is 4 times, the parentheses, negative 1. Not 4 minus 1, but 4 times negative 1, which is negative 4. So we'll do a quick check. And we used 2 mathematical properties there. We combined like terms, and then we used the multiplication property of equations. 4n. One thing, check into the original equation. If I say solve and check, that means half the points go to solving, half the points go to checking. If you check it into the equation that you created, you'll get no points for checking your work. You need to check it into the original equation, because what if you made a mistake here, then you check it into here, and of course it comes out right. Some students will actually go to this point and check it, or they'll even go to some other point and check it, and that's not quite right. So 4x minus 8x equals 16, and we're asking ourselves, does it equal 16? Everywhere this is x, we're going to put a negative 4. So 4 times negative 4 is negative 16. Negative 8 times negative 4 is a positive 32. And we're still asking ourselves, we're not done yet. Remember, I said I want you to get to a number equals a number, not 2 numbers being added together equals a number. Negative 16 plus 32 is 16, and 16 does in fact equal 16. So this would actually be the most proper way to do this type of problem. Listing the mathematical properties, actually solving it correctly, and then checking it. And if you do all that, you're pretty golden. Now here I just said solve, so I might not give you extra credit for checking, because checking is to your benefit to make sure you walk out of the class knowing that you got it right, or pretty sure you got it right, but you might earn a little bit of extra credit by listing the mathematical properties. So we're going to reconsider the previous example, thinking in terms of division. So this 2x, remember I had you multiply it by negative 5 over 2, the reciprocal. But let's look at this in terms of division. Negative 2/5 times x equals 6. We're going to divide both sides, because remember in the 3x equals 6 problem, I'm sure your instinct was to say, oh, we'll divide by 3 and we get x equals 2. Well, why can't we do that here? Divide by negative 2/5. Remember, when you divide a number by the same exact number, you end up with 1. So that should give us an x, because negative 2/5 divided by negative 2/5 is x. But now we're stuck with this really ugly looking thing. But this really ugly looking thing is 6 divided by 2/5. And remember, we learned how to do this in chapter 1. This equals 6 times 5 over 2, and I did lose my negative sign, so I'm going to reattach it right there. Now, 2 goes into 2 once, 2 goes into 6 3 times, and now we have 3 times negative 5, and 3 times negative 5 is negative 15. So our x still equals negative 15, but when you're listing your mathematical properties, it's still the multiplication property of equations. Now there is the property of 1 in division in chapter 1, namely that any number other than 0 divided by itself is equal to 1. But that just explains why you're doing this side. It doesn't explain why you're doing the other side. And the multiplication property of equations does explain why you're doing it to both sides, okay? So we want to make a 1 here, so the property of 1 in division allows us to make a 1 on this side, but this property does not allow us to do this to this side. That's the multiplication property of equations. So you might want to make some flashcards with an example on each flashcard so that you can start getting to know what's happening there. I'm going to pause for a quick second. Okay, 3.2 is this weird section in this chapter that doesn't really seem to fit very well. It kind of interrupts the flow between what's happening with 3.1 and 3.3, but it's there and we're going to work through it. The one thing I'm going to point out is that I created this 3-page handout in the fall of 2013 for students to read in advance so that they would have it for their classwork and group work, because percent equations tend to be very difficult for students to handle because they're not just something easy that they can figure out in their head most of the time. And there's a lot of calculations involved which students don't want to have to deal with. But we've got to get through it. So instead of going directly from the book, as I would normally do in a class lecture, I'm using this handout to help you understand what's happening in the objective. Objective A is to solve application problems using the basic percent equation. This one section has proven to be one of the most difficult for students to understand in the entire class. It doesn't mean it's the most. You will definitely see harder sections, but on your first exam, this might be the second hardest section you'll see. Second or third. For some of you, maybe the first. So instead of me reading through this, because you guys can read through this, this is a fully typed up explanation of Objective A. It's fully typed up. Every part of it's typed up. I explain how to translate. I give you hints about what to do. One of them being you always have to work with decimals, not percent, so you have to convert before you start working with things. I give you the different examples with the base amount percent method, which is how they do it in the book, PBA. Some of you learned it some way, and you know how to do it, and you do it perfectly fine, and that's fine. Whatever method works best for you. But some students have learned it a specific way, but they still don't quite understand how to do it that way. So I need you to learn it this way if you don't really understand the way you want to do it because you've learned that in the past, or you need to figure out how you've learned it in the past and make that work for you. So I'm going to have you read through this, and we're not going to spend video lecture time on it. I give you the answer, and I show you pretty much how to break it down. You just have to complete the math, and please do take the time to complete this math because you will be doing classwork, you will be taking quizzes and exams that involve these types of problems, so you definitely want to see where this math is coming from. And I give you the answers to each of these, which I hope are correct. None of the students have ever pointed out that it's not. So, at the end of page 27 is the end of that handout, I believe. And then at the top of page 28, we start talking about something a little different. One formula dealing with percents you must get to know now is Q equals AR. This formula does not go away. You have to understand this formula right now in this section, 3.2, so that when you see it again in a much more difficult context, you're not completely thrown by it. It's called the percent mixture equation. Q is the quantity of a substance in a solution. For example, the percent of fat in milk is Q. Okay, it's the quantity of fat in the milk. It's not the amount of milk. A is the amount of the solution, or in my example, the milk. And R is the percent concentration of the substance. So when we're talking about 2% milk, it's 2%, R would be 2, and then it's a gallon of milk, and then you'd have to figure out the quantity. Q equals 1 gallon times the 0.2%, and then you get a certain amount of a gallon that has the fat in it. So we're going to look at this example involving cereal and the percent concentration of sugar in cereal. And we could choose juice or anything else. The concentration of sugar in a breakfast cereal is 25%. Now, our Q equals AR only has one thing that has a percent in it. It's the R. So before we even write anything down, though, we need to convert this. So this goes back to our chapter 1. How do we convert a percent to a decimal? Remember, I stated that the percent always looks bigger, and that's how you know to convert percent to decimal. Divide by 100. So we have to take this 25 and divide by 100. And you'll also remember that percent means per 100. So 25 over 100 is 25%. And now the 25 goes into the house. The decimal point goes to the right of the 25 because 25 is a whole number. And then you proceed with the division problem. And we all knew where we were going with this. You're just moving the decimal place over 2 places. But I actually do want to see the work on a quiz or an exam. If there are 2 ounces of sugar contained in a bowl of cereal, how many ounces of cereal are there? So now we're stuck with the Q and A, and we're like, I don't know which one's Q and which one's A. Maybe one's Q and one's A, we just don't know. So we have to go back to our definitions. Remember, Q is the quantity of a substance in a solution, which means the solution is the larger amount. If there are 2 ounces of sugar contained in a big bowl of cereal, that's got to be more than 2 ounces of cereal, otherwise it would be 100% sugar. How many ounces of cereal? So A has to be the number of ounces. Ounces is OZ. And this has to be 2 OZ of sugar. Now here's something to keep in mind. Whenever you're dealing with math, you always want to do a reality check. If you had switched these and gotten a certain number, that number would look very, very wrong. It will look very, very wrong. Either it'll be super huge, like, 115 ounces or something, or it'll be super small, and you're going to be like, that just doesn't really make sense to me. So try switching the numbers and doing it again. So we have our Q, which is 2. A, and I'm just going to leave A as A, and then 0.25. It's A times 0.25. So we're going to use the multiplication property of equations and quote-unquote divide. We want to isolate A, so we're going to divide by this 0.25 because 0.25 divided by 0.25 equals our 1. But whatever we do to one side, we have to do to the other. So now our A equals something. It equals 2 divided by 0.25, and this is where students are going to get stuck a little bit. Now I'm going to do some work over here. 2 over 0.25 equals 0.25 stays on the outside because the 2 drops in. Remember, the numerator drops into the house. Now this is where students also get stuck. They forget to put the decimal here because 2 is a whole number, and they forget to move the decimal up. Except in this one, I don't want you to put the decimal up there just yet. We're not dividing by a whole number, and we have to have the outside as a whole number. So we go 1, 2, and now it's 25. And we go 1, 2, and now we add zeros to the buckets that are left behind. Now we move the decimal up. And this makes it look a little bit messy, so we'll rewrite it. So now we have to ask ourselves, 25 goes into 200 how many times? Well, I know that it's 8 because there are 8 quarters and $2, and that's where it just takes some mathematical experience and real life experience to understand how to process this with quarters. You have a remainder of 0, which means the answer is 8. But 8 what? Remember I said in one of the previous videos that when dealing with word problems, you need to have words in your answer. How many ounces of cereal are in the bowl? So we could just say 8 ounces. You could say 8 ounces of cereal, but I know we're talking about cereal. So 8 ounces. And that's what I have here in the answer box. So hopefully you followed that a little bit. You can always pause the video and rewind it and listen to it again. Or you can go to the textbook and look at the textbook examples. Or see me in office hours or go to school whenever you're confused about anything, not just that particular problem. So objective B is to solve uniform motion problems. And this is something you're going to see again multiple times throughout this course, so it's better to understand it now when problems are a little bit easier than they will be later on. Definition: any object that travels at a constant speed in a straight line is said to be in uniform motion, which means that the speed and direction of an object does not change. It's just a definition. Don't worry too much about it. The big thing is this formula. Distance equals rate times time. distance equals rate times time. As with the percent problems, and just memorize it, just think about it every day before you go to bed. D equals RT, Q equals AR. As with the percent problems, we have 3 variables, so we should have 3 relevant numbers in each problem. Sometimes you have to look beyond the numbers in the problem to see what's happening. Sometimes conversions are required to match the units. So we're going to try this problem. A plane can normally fly or travel at 250 miles per hour in calm air. And you'll see some problems in this chapter and in later chapters that talk about calm air versus turbulent air, or headwind versus tailwind. So it can travel that fast in calm air when there's no air helping it by pushing it forward and there's no air pushing it back against the plane. But this particular plane is flying into a headwind. So when we draw a plane, this is my funky plane with 1 wing apparently. Maybe it needs 2 wings. How many wings are on a plane? Just 1, but I've unbalanced it, but that's okay. We have this weird, lovely plane flying along, and it's going 250 miles an hour. A headwind, it's flying into a headwind. Headwind means the headwind is going that way. So the plane isn't actually going 250 miles an hour because the wind is pushing it back 25 miles per hour. So the plane's real rate is 225 miles per hour because it's 250 minus the headwind, which is 25 miles per hour. So now the question is, how far can the plane fly in 3 hours? Oh, that looks like a time. So let's take our distance equals rate times time formula. How far? So we're looking for D. Our rate is 225 miles an hour. Our time is 3 hours. Now, no conversion of units were needed. We're having 3 hours. We're in miles per hour. So we're going to end up just fine with our units. So our D equals 3 times that, which is 675 miles. Now I'm going to show you, I shouldn't have put those hours there because I wanted to do that separately. I'm going to show you what's happening. The distance is miles per, meaning the fraction bar, hours, and we're multiplying by hours. And notice, just as we're dealing with numbers, the hours become 1 because hours divided by hours is 1 and hours divided by hours is 1. So that's why our distance ends up being miles. So I just wanted to explain that just in case you're always wondering when you're dealing with these problems, why does it end up being miles? Because our units end up that way. So that's the bottom of page 28. Now we're going to look at this example. Ted leaves his house at 8 a.m. and he arrives at work at 8:30. If the trip to work is 15 miles, determine Ted's average rate of speed. So determine Ted's average rate of speed. In other words, find R. So we have our distance, D equals 15. What's our time? That's the question. So he left at 8, he got there at 8:30. So some of you are going to say, oh, it's 30 minutes. That's true, it is 30 minutes, but remember that our rate is miles per hour. We have 15 miles, we need something with hours. Because we have this, we need something with hours. So 30 minutes equals 1/2 of an hour. Otherwise, the 30 minutes and the hours are not going to go away. So we have our D equals RT. And if you write this formula every time you do one of these problems, you will memorize it without having to make a flashcard. And then we have our 15. We have our rate, which is unknown. And we have our half. And then we're going to divide by 1/2 or multiply by the reciprocal. The reciprocal of 1/2 is 2/1. So whatever we do to one side, the multiplication property of equations requires that we do to the other. So this becomes 1. Right, all these become 1, so that's why we're stuck with just our R. Now 15 times 2 is 30. So our rate is 30, and I didn't leave enough room there, 30 miles per hour. So this seems reasonable. He must be taking the streets to work, because it's just easier that way than taking the freeway. So let's see what would happen if you kept this 30 minutes. So we have our distance equals our rate times 30 minutes. And then we have to divide by 30, and then we have to divide by 30. Well, what's 15 divided by 30? Half. So now our rate is a half. But a half of what? We don't know. We've got miles per what? So it's important. Is it per hour? Well, you didn't start with an hour, you started with a minute. So if we look at the units, we had miles equals R times minutes. And we divided both sides by minutes. And yes, this is ugly, but it says minutes. Miles, not R. So now we have that our R equals miles per minute. So he's going a half a mile per minute. But do we have miles per minute on our speedometer or odometer in our car? We do not. We have miles per hour. So if you get something that looks kind of funky, you want to double check what you've done. If you're talking about distance, you want to make sure that you're talking about miles per hour, or meters per second if it's a physics problem or something like that. Just make sure that your units match up. And I believe this is going to be the last one in this section and the end of this part of the video. Two cyclists start from the same point, and really starting point. Visuals can be very helpful. They move in opposite directions. One cyclist, and I don't draw, so I'm just going to put a person there, is traveling at 8 miles an hour. And I'm going to do the 8 miles an hour over here. And the other one is traveling at 9 miles per hour. I can't speak anymore. After 30 minutes, how far apart are the two cyclists? This actually requires the D equals RT formula twice. We need to find the distance that this guy traveled and add it to the distance that this guy traveled. So this guy went 8 miles an hour for 30 minutes. So we're talking about a half an hour again. So this guy went 4 miles. This guy went 9 miles per hour times a half. Now we're going to convert that to a decimal for purposes of distance. 9 halves is 4.5 miles. We're not done yet. It says how far apart. So this arrow, this distance is 4 miles. That arrow is 4.5. So how far apart are they? You have to sum them. So they are 8.5 miles apart. And if we scroll down, that's what we get. So I know these are harder problems. So you're going to get to practice in class. You're going to get to practice on your homework. You can rewatch these videos or YouTube some other videos that might be helpful to you. Or try the textbook. The textbook gives examples, and I try to use exercises or things that the textbook doesn't explain. So there are extra explanations within the textbook that will be helpful to you. So we're going to stop this video since it's going a little long, and that will be 3.1 and 3.2. And please don't forget to definitely go through that 3.2 objective A part, because I did not read through that. It's pretty spelled out for you. It's all typed out for you, those percent equations, and you really have to understand those. So we'll see you in the next video, which will start off at 3.3.